So let's go ahead and let's start to do some more examples with our chi-squared goodness of fit test. And whoops. So let's look at a data set with random numbers. So I'm going to go, and we've already kind of pre-written this, but I'm going to create a random number list from 0 to 10, 300 samples. I'm going to take this data set, and actually I'm going to set my working directory. Set as working directory. I'm going to call it randat. Randat is going to be equal to read.csv, and it's going to be random. Hopefully it's there. Random. There we go. Random.csv. And enter that. Good. So now I'm going to. So if I look at my randat, I have a column little x, and again, ignore this other column, it's just a counter. So I have this column little x, and it's showing me my random numbers. That's just, the other column is just a counter. So I want to count how many, 6s, 7s, 8s, 3s are in that list. So I'm going to do a table where I count, oops, not my RDAT, my randat. Randat. And I'm going to count what's in there, how many times are repeated are these values. So 0 is repeated 37 times, 23, 33, 28, 26, 30, 35, 23, 18, 19, 29. So those are my observed values. From this random number generator, predicted goes to, it should be 1 divided by 11, and then repeat that 11 times, because I'm 0 to 10, we have those values. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And remember, they have to sum to 1 for your predicted values for our chi-squared. So we've got observed, we got predicted, chi-square test, and then we say x equals observed, p, equals expected, predicted, and then let's look at our chi-square. I think we can set our conf. No, let's look at our chi.squared again. Chi-square.test. So we set those values. I think we're just going to get our p-value out of it. Yeah. So we can go ahead and we see our p-value is 0.14. So what is our problem is asking us at the 1% significance level. So really we're looking, and again, frequency is the same, frequency is different. So this is going to be our alpha. And remember the new, if you do the hypothesis testing protocol, so you can calculate the chi-squared by hand. You can do it with this, with our tool for chi-square as well. And actually, yeah, we can do that here. So we can look at, actually you can calculate, this is not the value here because it's a different data set, but we can calculate our chi-squared theoretical, which would be this, because again, our new is equal to k minus 1 minus r. There's no fitting parameters here. So we have basically 11 possible outcomes for a random number, so it's 10. So this would be 0.01. That would be our critical chi-squared value. And if we look at our actual chi-squared value, it is 14.673. So that is going to fall where? Oops, not in my emails. That is going to fall inside here. So that would be a do not reject. So does that make sense? Yes, because our p-value needs to be less than 0.01 to be in the reject. So there we go. They are not statistically significant. Next problem, casino. Ace Rothstein suspects a player as casino is cheating. He asks you to test if the dice are true. And he gives you the following data set for the outcome of rolling two-sided die. Wants to make sure there's no cheating. Ran experiment 800 times. So our chi-squared, we can have values from 2 to 12, right, for dice. That's effectively the values. If you have two six-sided dice, let's see. If you have two-sided dice, that's going to be essentially how you add those together. So we can actually look at this here. And excuse me for, I'm pulling up, here we go. Let's see here. We're going to get our, basically, values. So, excuse me. So, we are going to get, I'm just getting my other value set up. So, we can read in our dice value, just like we did previously here. So, we can go ahead and say dice dat goes to read.csv, dice.csv. We got dice dat. We can do the table again, which is dice dat. And then we can look at those values. So you can see the distribution of these values. So again, we can go ahead and set up observed. And then, although you should use different variable names, 86, 74, 75, 76, 71, 63, 82, 59, 62, 81, 71. Those are my observed. My expected values, you may have to do some research about this. To get 2, it'd be 1 over 36, then 2 divided by 36, then 3 divided by 36, then 4 divided by 36, then 5 divided by 36, then 6 divided by 36. Let's see, 6 divided by 36. And then we're going to go back down and copy the, 5 divided by 36. 5 divided by 36. 4 divided by 36. 3 divided by 36. 2 divided by 36. 1 divided by 36. That's our expected. We can do chi-square test. And we do x equals observed, p equals predicted. And we can observe our value. And that's a pretty big... So this is our value here. So we are way, 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 way well left of that. So, actually, excuse me. We are well inside of that, I should say. And the p-value is also in the do not reject as well. So there we go. We got it. Now, next time, we're going to finally answer the question quantitatively, is this truly a Gaussian? So we'll see you all next time. Thanks. Bye.